Okay, so we're still dealing with parabolas, still dealing with conics. In this case, though, we're going to look at the conics, the parabolas that are not functions. Like if you take a look at this parabola, it opens sideways. So if you did the vertical line test, this would not pass the vertical line test. So we're no longer talking about quadratic functions, but we are talking about quadratic equations, and they still are parabolas except they open to the side. In this case, we still have our vertex. The vertex point is still HK, and we still have our directrix and our focus. And each point on the parabola is the same distance from the focus as it is from the directrix. So those distances are the same. X, Y. The distance from this point to the point on the parabola is the same as the distance from the point on the parabola to the focus. What I want to do is I want to talk about finding the focus and the directrix. I already showed you how to derive the formula here um, with a vertical parabola. It's the same thing pretty much with the horizontal parabola. The focus point, though, the point that is the focus, this distance is still going to be called P, the distance from the vertex to the focus. And because it's a parabola, the distance from the vertex to the focus, because the vertex is a point on the parabola, has to be the same as the distance from the vertex to the directrix, so that this distance is also P. That'll help me to find the ordered pair that gives me the focus. Since I know the vertex is HK, then this x value over here, I have to take the original x value of the vertex h and add to it p. So for the focus, the x value is going to be h plus p. But the y value is still going to be k because they're still on the same horizontal line. So the y value is still just k. And then for the directrix, well, let me see. This point back here, well, if I take the entire distance h from the y-axis to this x value, that distance is h, and I subtract from it the value of p, back here I have h minus p. So the equation of the directrix is, in this case, since it's a vertical line, vertical lines have equations x equal, and then we're just going to take this x value right here, which is uh, h minus p. So there I have the equation for the equation for my directrix, and I also have the ordered pair that gives me my focus. All I need to know is how to find p. Well, just like before, in this case, the equation is going to break down into y minus k, and let me do this in black, y minus k squared equal to 4p times x minus h squared. Nope, it's not squared, just x minus h. Just x minus h. So compare this to the one where the axis of symmetry was vertical. In this case, the axis of symmetry, the line that goes through the vertex and the focus, is a horizontal line, and the directrix is a vertical line. In the other example, it was opposite. We had the directrix being horizontal and the axis being vertical. So the parabola opened up or down. When you have this case, the parabola will open either to the left or to the right. But we still use the same numbers. HK will be the vertex, HK. P will tell us how far it is from the vertex to the focus and from the vertex to the directrix. So let's go ahead and look at an example. So it says graph the function. Well, this is actually not a function, so that is a mistake. This is not a function. So I should say graph the equation, because this one is not a quadratic function actually. This one is just an equation, and when we graph it, we're going to see that it's actually not a function. So graph the equation. identify its vertex, focus, directrix, and axis. So let's see here. Well, just like before, in the other example I gave you for the one with the vertical axis, it's in this standard form of a conic. In this case, though, before a was equal to 1, so I had the quadratic x squared term, but there is no quadratic x term here in this case. That's how I know this parabola doesn't open up or down. That's how I know this is not a quadratic function. But I do have the y squared term. C is equal to 1, and I do have the term y squared. A is equal to 0, that's why there's no x squared. B is also 0, that's why there's no term with a product of xy. So it is a conic, and I don't want it in that form. I actually want it in this form, the form that we just looked at. So what I'm going to do is I'm going to complete the square on y. Notice that there's a quadratic and a linear y. I'm going to keep those two terms on the left hand side, and I am going to put all the other terms on the right hand side and complete the square. In this case, I'm going to complete it on the variable y. So to complete the square on the variable y, I need to keep y squared on this side and the minus 4y because those both involve y. And I'm going to complete the square using those two. I'm going to add 8x to both sides. And I'm also going to subtract 12 from both sides. Subtract 12. Okay, so on the left side, the number that I need to complete the square is half of this middle term squared. Half of 4 is 2, 2 squared is 4. So the number I need to add in is a 4. That's the number I need to add to complete the square here. So I'm just going to add that 4 in. But you can't just add 4 to the left side unless you also add 4 to the right side. So I add 4 to the right side also. Oops. Say add 4 and right add 12. Absent-mindedness. So I add 4 to both sides. All right, so now what I get is on the left side, I can factor that, which was the point. I wanted this binomial squared. Y minus 2 squared is what I get on the left side. On the right side, I have 8x, and then negative 12 and positive 4 is negative 8. So I'm well on my way to achieving that final form. I have the left-hand side perfect. All I need to do now is work on the right-hand side. All right, so let's see. On the left-hand side, I have exactly what I need to identify k. I know that k in this case is going to be 2 because I have y minus 2 squared on the left. Notice k is always associated with y. And on the right side, I need to factor whatever the leading coefficient is of x. So I'm factoring out an 8, leaving me with x minus 1. And the last thing I need to do is I need to figure out what the other factor is of 8 that is not the factor 4. Because remember, I need to factor a 4 out of whatever the coefficient is here. So I have my y minus 2 squared still. And I want a factor of 4 to come out of this expression. If I take out the factor of 4, this 8 turns into a 2, and then I still have my x minus 1. So now I have everything I need. I have everything I need identified. I know that h, which is associated with the x over here, h is 1, k, k is 2, and p is the number 2 also. So that being said, I now have everything I need to be able to graph my parabola. Remember this graphic here. What I'm going to do is I'm going to graph the vertex as hk. I have h and k. And then from hk, I'm going to add p to h and keep k to get to the focus. And I'm going to subtract p from h and let x equal that number to get the directrix. So I'll have all those things. Let's go ahead and do those. All right. So, like I said, we have this parabola now, I know that the vertex is always the point HK, so that one is a no-brainer. HK is 1 comma 2. Now for the focus. Now remember, this parabola opens to the side, so if I want a point that's either to the left or right of this point, I have to modify the x value. So the focus in this case is going to be what I get when I take h and add to it p. H plus p is 1 plus 2. That's the x value here, 3. And I keep the y value the same, k. K is equal to 2. So the focus is at the point 3, 2. And now for the directrix. Well, the directrix is the equation of a line. And since we know the equation of this line is the equation of a vertical line, it's going to be x equals some number. Well, what is that number? I'm going to take the x value of the vertex, which is 8, and I'm going to subtract p from it. 1 minus 2 is negative 1. And then the last thing for the axis of symmetry is now a horizontal line. So for the axis of symmetry I know is going to have the equation y equals something. And I also know that the axis of symmetry goes through both the vertex and the focus. So it's y equals 2. All right, now with all this information, I can graph my parabola. All right, so let's bring this information over and do our graph. All right, so the vertex is the point 1, 2. So let's graph the point 1, 2. Let's do that in blue. The point 1, 2 is right here. That's the point 1, 2. The focus. The focus is the point 3, 2. The point 3, 2, 1, 2, 3, 2 is right here. That's the focus. And the directrix is the line x equals negative 1. So the directrix is this line right here. This, this vertical line here is our directrix. And all the points on the parabola are the same distance from this green line that they are from the red dot. And remember, the parabola always open towards the focus. Parabolas always open up towards their focus. So wherever the vertex is, we're going to open this up towards the focus. The axis of symmetry is the line y equals 2, which is this line right here, the axis of symmetry. So the parabola will be symmetric to that line. But the only points on the actual parabola are these points I'm about to draw, which are the points opening towards the focus that are equidistant or the same distance from the focus and the directrix. So the parabola opens like this to the right. Remember, it always opens toward the focus. So that means that if you can identify H, K, and P, H, K, and P. P is the distance from between these two and between these two. If you can identify H, K, and P, it should be relatively easy to graph a parabola, give its vertex, focus, directrix, and even the axis.